there are some concepts like it has to be considered when you're working in a real-time environment and very big environments, right? So there are two things very important: a core group and a node group. So what is a core group? So in IBM, I have prepared everything as much as data I could get, so that this will be helpful for you to understand the concept. Now you cannot by heart all these things. Sometimes you may be asked in the interview about this thing, and it is also helpful when you're working in multi-environment and multi-node and high availability kind of architecture, right? So apart from this, there are some other properties that if required, it has to be taken care of, and that depends upon the type of uh, high availability you you will be working in your environment. So usually whenever you create a DMGR profile or a application server profile, what are the things that are created? We have learned this one. So the top level component that will be created is a cell, and inside a cell, if it is a standalone, there will be only one node. Inside a node, there will be one application server JVM. So if you are federating this application server node with the DMGR, the application server will lose its current cell, and it will be federated with the DMGR cell, and the DMGR cell becomes a master configuration, and the node, whenever you synchronize the settings, the configuration will be obtained from the DMGR cell and stored in the local repository. So we know this concept. But there is one thing, uh, for each cell there will be a core group. So what is a core group? A core group is a fundamental concept used for managing and coordinating various administrative tasks and configurations across a WebSphere cluster, right? So this core group concept is very useful when you are working with a cluster, and it will be helpful in managing and coordinating various administrative tasks and configuration. So whenever you do any admin tasks, like if you are creating a cluster, adding members, and deploying an application, mapping modules with the cluster members, and changing the load balancing algorithms, all these types of configurations will be managed and coordinated with the help of a core group, which is a fundamental concept for high availability clustering. So it's a part of underlying infrastructure that supports high availability, failover, and consistent configuration with the cluster environment. So there are few things. What is the purpose of a core group? So in core group, there will be a cluster coordinator. There will be, so actually in each cell, we have, in our current environment, we have federated two nodes. One node in the local VM and the other node on remote VM. So when you federate it with the DMGR cell, the DMGR cell, by any cell, by default, it contains a default core group called, the name itself is default core group. So default core group, it is a concept like whatever the components are available in the cell. So in our current DMGR cell, there is a DMGR server, DMGR node, local node with a cluster member, and remote node with a cluster member. So whatever is available in this cell, everything, all the services will join this core group. Why? Because to maintain and manage and coordinate for various configurations and high availability, right? So each and every server will take part in the core group. So the core group has functionality that will be helpful for high availability, failover, and configuration. So what is the purpose? So cluster coordination. First thing is there are two important things: cluster coordination and configuration synchronization. So core groups are used to manage coordination and communication among the servers in a WebSphere cluster. They handle various administrative tasks and runtime activities that need to be synchronized across the cluster. All right. So whatever the settings you configure on admin console regarding the cluster, all other the cluster members, they coordinate. The cluster members talk to each other, they communicate to each other, right? So all these activities are taken care by a cluster, a core group. Core group. So cluster coordination. So if one cluster member is failed or overloaded, or the sessions that are engaged with one cluster member has to be taken care by another member in case of failures. So there will be coordination between cluster members. So that type of coordination will be supported by a core group. So core group has multiple things. We'll see one by one. Configuration synchronization. Core groups helps in synchronizing configuration changes and ensuring consistency in cluster. So simple. The configuration synchronization, whenever you can do a static configuration which requires a cluster member restart, and you can also do some dynamic configuration regarding the weight and the load balancing that can instantly take effect. So static and dynamic type of configuration and its synchronization will be taken care by a core group. Now functions, configuration management. So core groups facilitate the propagation of configuration changes from the deployment manager to all the individual cluster members. Right? So propagation means what? Reflecting the configuration changes to the respective server. So you see, we have we actually generate the plugins, right? So there is one more option called propagate plugins. So whatever the path you have mentioned for the plugins, it will propagate. Means it will copy the configuration file to the respective path. So what exactly it is? It is core groups facilitates the propagation of configuration changes from the deployment manager cell to the individual cluster members. So whenever you do any changes, it will propagate those configuration changes to the respective cluster members, even if they are spanning across tens of machines. So this includes updating the resources, application deployments, and other settings. So whenever you map modules to the cluster members or a cluster, so the application actually, if there are two cluster members in the cluster and you're deploying an application and you're mapping it to the cluster, so the application will be deployed on all the cluster members, right? So that is what it is saying here. So configuration management, application deployments, whenever you deploy an application, it will be deployed on both the cluster members. Even these cluster members are on multiple machines, multiple VMs in different regions. So all these settings and application deployments and updates, everything will be taken care by a core group. So failover and recovery, they play a role in failover process, ensuring that if a server fails, the cluster can recover and maintain operational integrity. Core groups help manage the failover of resources and services between cluster members. So as we have already discussed, if one server is failed in a clustered environment, immediately it will be taken care and all the requests that were engaged with these servers they will be routed to the other servers. So the load balancing and the workload management will be handled, and also the failover. So it plays a very important role. So if a server is failed while executing a request, the user should not get any error or any issue. The user will continue accessing the application even if there is a server failure, and that will be those requests will be recovered by the other cluster members. This works with the session management. So how the sessions are configured in the cluster? It can be configured in two ways. One is memory to memory, and the other one is session persistence. Persistence means the sessions will be permanently stored in the database. If it is a session replication, memory to memory, then the sessions will be stored in the heap memory that will be accessed by that. Okay, let me tell you in this way. There is a cluster member 1 and cluster member 2. Cluster member 1 will store its sessions in its own heap memory, and cluster member 2 stores all the sessions in its own heap memory, and that part of heap memory, the session data, will be shared from 1 to 2 and 2 to 1. So there will be, it is a shared resource. The sessions will be shared across all the cluster members. All right. So this will be taken care of with the help of session management. Membership management. Core groups maintain a list of active members and manage membership changes, ensuring that all the cluster members are properly accounted for and managed. So this one, in a cluster, actually in a core group that has high availability clustering, there will be a HA manager, which is high availability manager, that is responsible to define or to select a coordinator. So what is a coordinator? A coordinator is an entity in a core group that takes care of the other core group members that are participating in the cluster. So each and every cluster member shares a message in a regular time interval with this coordinator, and it will be responsible to find out who is active and who is passive. So based on this list, the cluster operates. So if one or two cluster members are not actively sending the messages to the coordinator, then the coordinator marks those cluster members as not inactive. So if it is marked as inactive, then the request will not be sent to those servers, right? So that is what it is saying here. So it maintains a list, and that list will be printed. Even there is a concept called, there won't be one coordinator. Actually, there will be multiple coordinating instances. So let us say it is sharing the work. So if you are defining only one by default there will be only one coordinator. But if you want to distribute this task, the taking care of all the cluster members across all the cluster members, these are called coordinating instances. So you see, we have seen like there is the DCS stack. There is some yesterday I told you. So remember this log message. So there will be a list called view. In that list, all the active members will have a membership, and it will be listed down. So if the coordinator itself is down, then its task will be shared to another elected member. So if the coordinator is down, the other member will be elected to play this role of coordinator, or else you have the option. So if a coordinator is if server 1 is selected as a coordinator, it normally does its work like executing the request, and also it will take a role of a coordinator that will utilize some system resources. So if one instance is acting as a coordinator, it should have a high system resources. So if that one fails, the other member will be elected as a coordinator. Or else you can also configure the membership management in such a way that the coordinator work will be shared across all the cluster members. Each cluster member will be acting as a coordinating instance, right? So this is the advanced concept, and I hope this will be very helpful for you in understanding what is happening behind the clustering. So you will see normally how the cluster is work, the functionality and the configuration, but in the background how the logic is working, right? Usually this will be discussed in the L3 level, but we are seeing it theoretically. So there are core group types. As I told you, there is a default core group, which is called, the name itself is a default core group for each cell. So that is called a system core group. This is predefined core group used by WebSphere to handle internal management tasks. It is automatically created and managed by WebSphere. So right now the DMGR is a master cell, and there are two nodes, and there is one cluster and two cluster members. So these all are part of one core group. We have not defined any user defined core group. It is a system core group called default core group. So you can also define a user defined core group. Administrators can create custom core groups for specific purposes, such as maintaining particular type of resources and applications within the cluster. So components, as I told you, there is a core group coordinator and core group members. So each core group has a coordinator role, which is responsible for leading the group in managing the tasks. So this coordinator role is typically held by one of the cluster members. And core group members, all the servers or nodes that are part of the core group are considered as a core group members. Each member participates in the group's activities, including configuration updates and failover process. Communication protocols. So in WebSphere there are multiple protocols, and usually the core group uses internal protocols to communicate among members. So this includes protocols for synchronizing configuration changes and coordinating failover. So the communication protocol that is used by WebSphere for there is an internal protocol called RMI over Corba that uses IIOP protocol, and for messaging it uses JMX, and there is what else? It also uses HTTP and HTTPS for sessions. This is also one protocol. So these are the different protocols that will be used based on the type of activity. Configuration and management, admin console, core group configurations and management tasks are usually handled through the WebSphere admin console or scripting tools. Administrators can define and modify core group settings as needed. So in summary, a core group in WebSphere Application Server is a crucial component for managing and coordinating tasks within the cluster environment. It supports configuration management, failover, and member coordination, ensuring that the cluster operates efficiently and remains highly available. Right? So how the core group works? These are the things we have seen. Right? These are the things, how it works. And core groups help maintain consistency across cluster members and facilitate smooth administrative operations. So this is, the core group is mainly focused on how the cluster members and how the high availability works. And what is a node group? In IBM WebSphere Application Server, a node group is a configuration entity that allows you to organize and maintain set of nodes and its servers that share common administrative tasks or configurations. So below are the its purpose. So the main purpose of a node group is node groups are used to group together nodes that need to be managed together. So this helps in simplifying administrative tasks by allowing changes to be applied to all the nodes in the group simultaneously. So I'm going to create a server, as I'm giving you a scenario right now. So I'm going to create a cluster that contains 4 different nodes on 4 different machines. So what I can do is there will be a default node group. But if you don't define any node group, all the nodes that you are going to create will be under a default node group. In your environment, there might be different types of nodes and different types of clusters with different types of templates, right? So you have the option to group the same node types into a single node group, right? So I am going to create custom nodes and I'm going to deploy an application, enterprise application. I will use one template. So I can group all the similar nodes into a group called a node group. So whenever you do any configuration changes on a cluster or any configuration changes on a particular node, and those configuration settings will be applied to all the nodes in the group simultaneously, right? And configuration management. Node groups enables administrators to apply configuration changes, updates, and management tasks to a subset of nodes efficiently. So whatever the configurations you do, it will be a subset to the nodes. So node group is the top level. So whenever the configurations are applied on the nodes, the first it will be added to each and every node simultaneously. All the changes, updates, and management tasks. So functions, configuration. Whenever an administrative changes are made, such as updating server settings or deploying applications, it can be applied to all nodes within a group at once. So if you are deploying an application on the cluster and the cluster has got a node group where all the nodes are participating in that particular node group, and you are deploying an application, it will be applied to all the nodes within the node group. This is more efficient than applying changes to each node individually. Deployment manager node groups can help managing the deployment of applications and resources by allowing batch updates across all the nodes in the group. Administrators can monitor the status and performance of nodes within the node group collectively, making it easier to manage large environments. All right. So everything is about how the configuration changes and application deployments and usage of resources can be managed within a node group. So it will be applied to all the nodes at a time, at once. So everything is all about the same. I have given you all the details. You can go through it, and usage scenario also it is given. Node groups can be used to segment different environments, development, testing, production within the same WebSphere installation. So you can define in this way also. Each environment can have its own node group, allowing separate management and configuration. So in a single instance of WebLogic installation, you can define 3 different node groups: development, testing, and production. So on development environment, if you do any changes, So those changes will be applied to the node group that is under development. So you can segregate in this way. Load balancing and failover. While node groups themselves do not directly handle the load balancing, they can be part of a broader strategy where multiple node groups work together to provide load balancing and failover capabilities. So it does not actually take part in the load balancing and failover, but it plays a role in the load balancing and failover. That actually it makes the node group and its own nodes in the node group to provide the load balancing and failover. So the meaning is it will directly not take part in the load balancing, but it will be a part of broader strategy. So it plays a role like segregating all the nodes within a node group that helps to improve the efficiency in the load balancing and failover. Configuration management, it is everything about nodes, how the configuration and what kind of role it plays. And you can use admin console to create the node group configuration or else scripting tools. And this is very important. Differences from node group. So node core group versus node group. While both core groups and node groups help managing WebSphere clusters, core groups are more focused on internal WebSphere cluster coordination, right? So this will clear out your confusion if you have any in node group and core group. So what does it say? It says core groups are more focused on internal WebSphere cluster coordination, failover, and configuration synchronization. But node groups, on the other hand, are more focused about grouping nodes for administrative efficiency and management. So that is what the difference between a node group and a core group. So this summary again, it says the same thing. Like it is a logical grouping of nodes that allows admins to manage configuration changes, application deployments, and other administrative tasks more efficiently. So by organizing nodes into node groups, WebSphere simplifies the management of large complex environments, making it easier to apply changes and monitor the performance across multiple servers. So I hope you have got a basic idea why a node group and why the core group is required in a larger environment. So let us see. DMGR is running fine. We'll see both. Okay. System administrator, if you click on the cell and these are the nodes present in the cell. So these all are part of core group. I have seen somewhere deployment manager, DMGR, yes, core group service. So as I said, enable service as a startup. This is a default core group. So you can create a core group. What is a core group? Mm, Here. So under servers, you see there is a core group settings. So this is a default core group. The default core group cannot be deleted. You cannot delete the default one. If you click on the default core group, these are the core group servers. So all, as we discussed, all the servers in your environment. So right now DMGR cell is a master configuration under which all these servers are running. So there is a DMGR server, there are two clusters and two node agents for each node. These are the core group services that are available under default core group. And discovery and failure detection. Okay, so this is a totally advanced one. The core group actually it has uh, discovery concept, failure detection, and there is one more thing called uh, what is it? Listing. As here we discussed something, right? That it has a list membership. So this one, there is a separate name for this concept, uh, list view or something. So all these, it supports all these types of three types of concepts. With these three types of concepts, the cluster members will be coordinated. So failure and detection, it has got some parameters, heartbeat transmission, right? So 3000, 30,000 milliseconds. Minutes means what? For every 3 seconds, it will send the message. Discovery period. So discovery period is something, it's a time interval in seconds at which the discovery protocol runs. So increasing the value might decrease the use of system resources such as CPU. Decreasing this value might improve the detection of core group members. So finding